Hey everybody, how's it going? Here I am at school, all by myself. Nobody's here right now. It's lonely, I need to do some math, so let's get into this. Okay, so we need to finish lesson 2.2 today. Now, you should have your unit 2 packet ready to go. Oh, there, that camera. And turn to lesson 2.2. Now here's the deal. I have been sitting here trying to figure out exactly where it is that we left off, because I technically have technically have 8 different classes going on now, and that's just my college algebra classes, not to count the finite classes. So there's actually 12 different classes that I've got going on. That's the same as all your teachers doing. The same as that all your teachers have. So we have like twice as many classes now. So I've been trying to figure out where exactly your group left off in section 2. And I think I know, but if I'm wrong, don't freak out. We will touch base when you get back, and we'll make sure that we cover up any holes that I might have left untouched yet. So we started section 2. I believe that we did this example and this example, finding function values graphically. I think that we're ready for this next page here. Like I said, if I'm wrong, you and I can talk about that when you get back. Well, Wednesday, right? And we can talk about that and we'll get it all figured out. All right. Okay, so in those 2 previous examples, one of them here, we were given an input and we were finding the output. So we were given an X coordinate and we were supposed to find the Y coordinate. On the next page, it was exactly backwards. We were given a Y coordinate and asked to find the X coordinate. So we were given the output and had to find the input. So we've done both of those now. So now we have a function here where we have the equation for the function and the graph of the function. I hope you understand that I don't expect you to be able to come up with this graph on your own right now. That's why it's given to you, okay? So you are not expected to know how to graph this function yet. But we are just giving you the equation for the function. So that's the function represented analytically, and then we have the function represented graphically, and we're just giving you this graph. So from the graph, identify or approximate each of the following function values. If the value of the function does not exist, state that it's undefined. So for f of 3, that means 3 is an x coordinate. I'll go find the point whose x coordinate is 3. That's this point here. The y coordinate of that point is 2. So f of 3 is 2. F of -1, go to -1 on the x-axis, find that point. Its y coordinate is -2. So f of -1 is -2. For f of -3, I go to -3 and I don't see a point on the graph. But you see this arrow here, that means that this part of the graph continues indefinitely. Now I don't want you to freehand this line. I want you to notice that this line, look at what its slope is. If I start at this point, I go down 2 and left 1 and I'm back on the line. Down 2, left 1, back on the line. Down 2, left 1, down 2, left 1. How about if I do that again? Down 2, left 1. So this line should go straight through that point. And now I can see if x is -3, there's the point on the graph, and its y coordinate is -6. Okay, now they want us to use the equation. So we found these function values graphically. Now we're going to use the equation and find the same function values analytically. So to find f of 3, I'm just going to substitute 3 into my equation here. So -2, absolute value of 3 minus 2 plus 4. And let's work this out. This means inside the absolute value here, 3 minus 2 is 1. So now that's absolute value of 1 plus 4. Reminder that absolute value means distance from 0, how far a number is from 0. And the absolute value of 1 is just 1, because 1 is 1 unit from 0. Don't forget about the plus 4 there. So this is -2 plus 4, which is 2. And looky there, same function value analytically and graphically. Okay, I'm going to do that for f of -1 as well. So here's after I've plugged the -1 into the equation. Inside that absolute value there, I have a -3. Then we have to remember what the absolute value of -3 is. So if we look at a number line, if here's 0, if I go to the left 3, that's where I find -3. Well, what's its distance from 0? Well, it's 3 away from 0. So the absolute value of -3 is just 3. -2 times 3 is -6. -6 plus 4 is -2. Looky there, same function value analytically and graphically. We're going to do the same thing with f of -3. Okay, and here I've got my work shown for that if you want to check yours, but I still ended up getting -6, which is the same function value that I got graphically. Okay, let's go here to p of x, and why don't you go ahead and find these function values graphically real quick. We'll pause in 3, 2, 1, pause. Okay, here are the values that I found from that graph. Notice that this one we had to estimate a little bit because we couldn't find, we couldn't see exactly at p of 3 what the y-coordinate of that point is. That's kind of a drawback to representing graphs or functions graphically, is that sometimes we have to estimate a little bit. Okay, let's do this analytically. So we'll plug in -4. So p of -4 will be the square root of -4 plus 4, and then outside the square root is a +3. -4 plus 4 is obviously 0, and the square root of 0 is 0, so this is -2 times 0. So I'm just going to get a 3, and looky there, we got the same value analytically that we did graphically. Let's find p of 3. So -2 times the square root of 3 plus 4, and then a +3 on the outside. That's -2 times the square root of 5 plus 3. Now guys, normally I am fine with you leaving this answer like that, because that's about as simple as we can get. But let's see how we did on our decimal approximation here. So I'm going to type in -2 times the square root of 5 and add 3, and I get, that doesn't seem right. What did I do wrong here? You guys are probably yelling at me so hard because I don't know how to add 4 plus 3. 4 plus 3 is not 5. 4 plus 3 is 7. Hopefully right now you feel so much more vindicated, like thank goodness he found it. That was killing you, wasn't it? All right, -2 times the square root of 7 plus 3, and there's -2.29, so it's more like -2.3, right? If I round it, we did pretty good. For p of 5, -2 square root of 5 plus 4, and then a +3 on the outside. That's -2 square root of 9 plus 3. Square root of 9 is 3. And now I have -6 plus 3, which is -3, same value. Awesome. Okay, on the next page, it says, let's consider a function, and they give us an equation for it. The graph of f of x is given below, has 2 zeros. It says, what is the 0 of a function? Well, let me show you graphically, first of all. This point here and this point here are called zeros. Zeros are sometimes referred to as x-intercepts, but they're not exactly the same thing. I'm going to have to discuss that with you in class. But let me just say this about a 0. These 2 points have y values of 0, right? These 2 points have y values of 0. So a 0 is any value of x that causes the y value to be 0. So any x value that causes the y value to be 0. I don't like using 2b right there because that's my college professor Bill is not happy with me about that. If you were here when I talked about that, I might not have told you that story. Anyways, any x value, see, he's still got me thinking about it. Any x value that causes the y value to be 0, that x value is called a 0 of the function. Based on the graph, we can't determine exactly what the zeros of the function are, but we can say like between which 2 x values do they occur. So here's a 0 here, and it occurs between -5 and -4. So I'll say I have one 0 that occurs between -5 and -4. I have another 0 that occurs here between -2 and -1. says when you solve this equation, what do the results for x represent graphically? So when I solve this equation, if I set this equation equal to 0, -2 times x plus 3 squared plus 4 equals 0. If I solve that, what do those results represent graphically? Graphically, they are x-intercepts. Those are points where the graph crosses the x-axis. So graphically, those are x-intercepts. Graphical explanation means if you look at the graph, what happens there? That's where the graph crosses the x-axis because the y value is 0. The output is 0. Okay, let's actually find these values of x. So we're going to have to solve an equation here that has an exponent in it. Luckily, you solved equations like this in Algebra 1. So let's do it. Let's subtract 4 from both sides. And if you don't feel real comfortable solving an equation like this, I'm going to go through it step by step here. So I subtracted the 4 from both sides. Now I'm going to divide both sides by the -2. I'll put a little box here. When I divide both sides by the -2, these -2's will cancel out, leaving me x plus 3 squared on one side. On the other side, -4 divided by -2 is 2. Okay, our next step here, since we've got our exponent, we're going to need to take the square root of both sides. We're going to need a calculator for this though. When I take the square root, that exponent's going to go away and I'll just have x plus 3. On my calculator, I'm just going to go square root of 2. Boom, 1.41. We'll just call square root of 2 1.41. Please remember though, that when we do a square root like that, when we find what number squared equals 2, well, it could be a positive number or a negative number. So we need a plus or minus on that 1.41. If you square positive 1.41, you get 2. If you square negative 1.41, you get 2. So we need both of those. The last thing we need to do to solve this equation is to subtract 3 from both sides. So one of my zeros I'm going to find by using positive 1.41 and subtracting 3. The other one I'm going to find by using negative 1.41 and subtracting 3. So you have to do the positive and the negative. So this would be negative 2.5. Sorry, that was dumb. Negative 1.59. And then this one would be negative 4.41. Those are my two zeros. See, notice this one is between -5 and -4. This one is between -2 and -1. Okay, I'm going to show you another way to solve that equation using your calculator, but we need to do that in class. That is not a video thing. We need to do that in class. So if you didn't like this, I think a lot of you are probably able to follow that okay, but if you didn't like this, I'm going to show you another way to do that in class using your calculator, but we need to do that in class. When you solve the equation f of x equals -4, what do the results represent graphically? Well, when we solved f of x equals 0, we found the points whose y coordinates were 0. If we solve f of x equals -4, then we're going to find the points whose y coordinates are -4. Remember, f of x is the same as y. This is just like saying y equals -4. So what we would be finding is the x coordinates of these points whose y coordinates are -4. So when you solve f of x equals -4, what do the results for x represent graphically? These would be the x coordinates, I'm going to abbreviate coordinates, of the points whose y coordinates are 4. Okay, then it says state those values of x. So I can find those really easily right off the graph here. One of them is, if I look at this point here, it has a y coordinate of -4. Its x coordinate is -5. The other one here that has a y coordinate of -4, its x coordinate is -1. So -5 and -1, those are the x coordinates of these points whose y coordinates are -4. In summary, when you evaluate f of a, what does the result represent graphically? And when you solve the equation f of x equals a, what do the results represent graphically? When you evaluate f of a, you're saying a is the x coordinate, what's the y coordinate? So you're finding the y coordinate of the point whose x coordinate is this a value. When we solve this equation, we're finding the x coordinate of the point whose y coordinate is this a value, just like we did back up here in that problem. Okay, next page, for each of the following, use the given function to find either the y value given the x or the x value given the y. Use the equation, but verify your algebraic results using the graph. Okay, so we're supposed to just use the equation. Find g of -6. Let's plug in -6 here. Okay, so I have plugged -6 in for x into the equation. Remember that the absolute value of -4 is just 4. I have found my function value to be -1. What this means is that if your x coordinate is -6, your y coordinate should be -1. They want us to use our graph to verify that. Is this point actually on the graph? Let's see, there it is right there, -6, -1. So that verifies that I did that correctly. Find the value of g of 1. Okay, we'll do that. And I have found the value of g of 1 to be -2. That means we should have a point with an x coordinate of 1 and a y coordinate of -2. And there it is right there, x coordinate of 1, y coordinate of -2. For what value or values of x does g of x equal -4? Okay, so we're supposed to use our equation here. So here's the g of x function. We want to know for what values of x does this equal -4? Now again, I'm going to show you in class how to do this on your calculator. I'm going to go ahead and do it algebraically for now. So I'm going to add 5 to both sides. -4 plus 5 is 1. All right, so now I have this x plus 2 in parentheses. And when I take the absolute value of this, I'm supposed to get 1. So I want you to think, what are the numbers that if you take their absolute value, you get 1? Well, those numbers are 1 and -1. So I'm going to say this x plus 2 could equal 1, or x plus 2 could equal -1. Because 1 and -1, if you take their absolute value, you get 1. So I'll subtract 2 here. 1 minus 2 is -1. Subtract 2 here. -1 minus 2 is -3. Again, I'm going to give you another way to solve this equation on your calculator, and we'll do that in class if you didn't like this. Okay? So for what values of x does g of x equal -4? That means at these x values, we should have a y value of -4. So I should have a point whose x coordinate is -1 and whose y coordinate is -4. And let's see, -1, -4, there it is right there, -1, -4. I should also have a point whose x coordinate is -3 and whose y value is -4. Let's see, -3, -4, there it is right there, -3, -4, awesome. For what values of x does g of x equal 5? I'll go ahead and do that real quick. Okay, so since the y coordinate was supposed to be 5, so I just replaced g of x with 5. So instead of this g of x, I just replaced that with 5. And I set the function equal to 5, and I've solved it algebraically here. Notice that the absolute value of x plus 2 was equal to 10. So I said x plus 2 could equal 10, or x plus 2 could equal -10, because these are the numbers whose absolute value is 10. Again, I will give you another way to solve this on your calculator in class. These are the values that I got. So when x is 8, I should have a y value of 5. And when x is -12, I should get a y value of 5. Let's see, do I have those on the graph? Well, it's hard to tell, right? I'm not going to bother with actually extending that out right now. But, you know, that's kind of the benefit of the analytical, the equation, is because the graphical representation is limited there, and that it couldn't find the points whose y coordinate was 5. Okay, last one, example 4. This is it. We're almost there. Yay. Okay, we've got a square root function here. Find the value of h of -1. So we're going to do that using the equation. Okay, so I plugged -1 into my function here. I had to use my calculator a little bit to do square root of 5, but my final value is -1.47. And so when x is -1, the y value should be -1.47. Let's see, if x is -1, does that y value look like it's about -1.47? I think it does, so that's good. Find the value of h of 10. Okay, let's do that. Okay, so for that one, I've got my work shown here to plug 10 into that function, and my result was -5. So when my x coordinate is 10, my y coordinate should be -5. I can't really see that value on the graph here. There is a way for me to kind of verify that graphically, but we don't need to worry about it right now. But again, that's kind of the value of having the equation and not just the graph. For C, what value of x does h of x equal 1? So I'm going to take my equation here, and now they're not giving me an x value, they're giving me a y value. So I want to say my whole h of x function equals 1. So I need to subtract 3 from both sides. 1 minus 3 is -2. Then I'm going to divide everything by -2. Those -2's cancel. Square root of x plus 6 equals -2 divided by -2 is 1. To get rid of this square root, I need to square both sides. So now the square root goes away and I just have x plus 6. 1 squared is 1. If I subtract 6, 1 minus 6 is -5. That means when x is -5, y should be 1. If we look on our graph, there's that point right there at -5, 1. Awesome. For what values of x does h of x equal -3? So let's take my h of x function and set that equal to -3. I'll subtract 3 from both sides. -3 minus 3 is -6. Divide both sides by -2. -6 divided by -2 is 3. To get rid of the square root, I will square both sides. So x plus 6 equals 3 squared, which is 9. Subtract 6 from both sides, 9 minus 6 is 3. So I have found that when your x value is 3, your y value should be -3. Let's look on my graph. There's a point right there with an x coordinate of 3 and a y coordinate of -3. Okay, so there we go. We did it. Now, I need to just comfort you a little bit. I know that there were some equations there that are tough to solve. We had equations where we had to do the square root of both sides. We had equations where we had to square both sides. We had equations that had absolute value in them and all kinds of kind of crazy stuff there. I did go through and do those for you by hand today because they are things that you have learned how to do before. So there's nothing here that's just like you've never learned that, but it's been since Algebra 1. So please keep in mind that when you come back to class, I'm going to teach you a way to do that on your calculator so that you won't have to do it by hand every time. But it's good to know how to do those by hand. And by the way, the using your calculator thing is just for the time being. There will come a time very soon when we'll need to be able to do all those by hand. But if your hang up on that lesson was the solving the equations, then don't let that bother you too much. I will come to your rescue when you're in class again next time. What we really want you to get down is, am I being given an x value or am I being given a y value? Am I trying to find the x value or am I trying to find the y value? That's the meat of that lesson today, okay? So I will see you in class on, well, I think Wednesday, but I don't know exactly who's watching this and when you're watching it. So I'll see you when I see you. Have a good day. Goodbye now.